let's do the insert function now. Let's define the function that inserts a new key value pair into the search tree. This is actually a little bit harder than lookup because we have to create a new search tree. We can't just modify the existing search tree because we're in the functional paradigm. That means while we're traveling down looking for the right place to insert, we have to also be building the new tree. Let me bring in a diagram to illustrate this. So here on the left we have the original tree, on the right we have the new tree. Here we have the record corresponding to the original tree, and here the new record corresponding to the new tree. So we have x, t1, and t2. Now assume that k is bigger than x. That means we have to create a new right subtree. Now we're traveling down the right subtree. That means here, this yellow right subtree is new. Notice the left part is unchanged. So the new tree that we create has a part that is unchanged compared to the original tree, which is xv and t1. And then the right subtree has to be the new right subtree. So instead of t2, we put here a recursive call, insert kw t2, so which creates the new right subtree, and we then put it into the unchanged pieces. So the complete record here is in fact the new tree that we create and that we have to return. So let me define this now. So insert kwt, we have to do recursively. We will use the case t of leaf. So if we have an empty tree, then it's easy. We just create a tree that contains kw, and left leaf, right leaf. Now, in the other case, when it's not a leaf, we have a tree, key x, value v, so we don't have confusion between k and w, left t1, right t2. Also, we use the and then again. Here we have, for example, if x is equal to k, then we do something. Now we have three possibilities, so let me copy and paste to create the three possibilities here. X is equal to k, x is less than k, x is greater than k. So here, if x is equal to k, then again, things are pretty easy. We have to create a new tree, but we don't have to do any more recursive calls. We just have to decide what to do with the new value. We have found that x is already in the tree, so k is already in the tree. And what do? Do we keep the old value? Do we put in a new value? Do we make a list of all the possible values that we've seen? Well, assuming that we will update, that we're updating the dictionary. So in our specification, we say that we replace the old value by the new one. That means return a tree with key is x, value is w, and the left and right subtrees are unchanged. So that's an easy case. Now let's do the next case. X is less than k, k is greater than x. That means we have to change the right subtree, and the rest is unchanged. So key x, value v is unchanged, the left subtree is unchanged, and the right subtree is changed, so there comes the recursive call, kwt1, t2, sorry, there we go. And in the final case, x is greater than k, or k is less than x. That means we have to change the left subtree, and the rest is unchanged. So key x, value v is unchanged. We have to change the left subtree, so that's where the recursive call comes. Insert kwt1, and the right subtree is unchanged, and that's it. So here we have our insert function, a little bit harder than the lookup, but still reasonable. Let's see if it works. So let me do first a browse of t. Here you see the original tree. Let me now insert something in there. Let's say I want to insert, the key is fly, the value, the translation in French is mouche, into t. Now think for a few seconds, where will it go in? can stop the video for a second and try to imagine where it has to be inserted. So let me now run this. And you see where it is? It's here. It's after elephant and before mouse, before monkey. Is that where you expected it to be?